I remember when discussion I had with Bob Hancock in particular, where I had this phenomenon of phosphate release and uptake, and he said, well, if you should have a look at the cations, because phosphate is not released by itself, and it's a co-transport mechanism. So there, you should look at magnesium, potassium, calcium, sodium, and to see if any of those are co-released with phosphate. And so we had an atomic adsorption analyzer in the lab. And so I had done an experiments with from a batch test, taking many samples. And so the phosphate was being released and taken up. And then I looked at the metals, and they were released and taken up for magnesium and potassium. Just these two. Yeah. Not the other ones, but just these two. And when you added the molar ratios, it fitted perfectly at 1 cationic charge per 1 phosphate molecule. So that was, and Bob Hancock is the one that had suggested that. And I remember being in the lab and looking and looking up, being very excited about this.
So I would say this is a combined moment for both, like, okay, a tough time, but it ends up with a great memory as well.
And not long after that, there was a conference in Paris in 1984 on phosphorus removal. And I hadn't gone, I didn't have that in any paper because it was so fresh. But I drew this on a sheet and presented it on a transparency.
Yes. People are like
very interested.
Yeah,
because there was a debate whether it's physical-chemical or biological, but now it was clearly biological.
Okay.
You have ions, the co-transported with phosphate. It's a biological thing.
So it was like a moment that you never forgot, and maybe this has inspired you more about the research and to do more and more. And so, other than the phosphorus recovery or removal, what are the main areas that is Dr. Comeau is working on?
Well, I tried to work on this topic in Quebec, but in Quebec there is a lot of the drinking water sludge, and alum is used for drinking water treatment as a coagulant, and it's discharged into the sewer system. And it reacts with phosphate in the sewer system. And when it comes to the plant, it's not bioavailable for enhanced biological phosphorus removal. We studied it in a number of plants in Quebec, and there is minimal EBPR taking place, but not very much. So I work on other aspects related to phosphorus removal by physical-chemical processes, with hydroxyapatite in particular, with slag, steel slag in passive systems, and also working with aerated lagoons, because there are the 2/3 of the plants in Quebec are aerated lagoons. And so the dynamics of nitrification and of sludge accumulation in particular is becoming more and more critical. These plants have more than 20, 30 years sometimes. And so sludge has accumulated, and emptying them is very costly. So we do a number of aspects of this topic.
Yeah, we had some discussion recently about the lagoon and the aerated lagoon, and we were worried about the nitrous oxide emission from those lagoons.
Yep. So contaminants of emerging concerns is also an area that I touched a little bit, not very much, but a little bit with colleagues. And so that's where I collaborate with other people when I work on a topic that is a bit newer. And my expertise of a postdoc is working on soil bioremediation becomes useful because organic chemistry is needed for this kind.
So it's like, I can see it's like a diverse areas, because contaminant of concern. So what type of contaminant of concern you're focusing on?
Well, pharmaceuticals in particular, the healthcare products and the skincare products and but also microplastics.
Okay.
And the PFAS.
So how do you see, because nowadays the PFAS, when we talk about anybody, it's everybody like PFAS, so it's everywhere. How do you see that challenge?
It's difficult because if you take them out of water, they go into the sludge. What do you do with that sludge? It's contaminated with PFAS. Send them in the landfill. Well, in the landfill, it will migrate and you'll find it in leachate and it comes back to the environment. So it's a big challenge. And so there are a few techniques that are available. And if you want to destroy PFAS, there are electrochemical processes. Thermal is definitely a good one. It's expensive, but it's a technique that works. And there are some other methods of destroying the very strong carbon fluoride link. But it's challenging. It's an area where there is quite a bit of research being done, and there's a lot of needs for this topic. So I didn't work very much on that, but I touched a little bit on this. But that's why as a civil engineer, which is my training, we lack a background in science. And so that's one aspect that I completed when I did my master, and mainly at the beginning of my PhD. So I had no courses in organic chemistry, nor microbiology, nor biochemistry, or very fundamental understanding. But I took undergrad, first-year courses in each of these topics, and even an advanced course in microbiology, which has been fantastic for my career.
Yeah.
So, and I remember talking with Mark van Loosdrecht, and was an eminent researcher in the field of wastewater engineering. And he's very strong in wastewater engineering and microbiology, applies microbiology. So he goes to these two types of conferences.
Yeah,
He's an expert in both of them, but he has a very strong science background and applied engineering background. And I think that's the secret.
Yes.
And I know some people who have had this kind of background with strong science, strong engineering. Yeah, but the science is often missing in our training. Yeah.
Good. So talking about this, I think now it's like, okay, we say that we can overcome that kind of lack of expertise sometimes, especially in the environmental sector, with collaboration, because without collaboration, you'll not be able to, handle all the topic that is, okay, scientific perspective, engineering perspective, practical perspective, microbiological perspective, So I think, how do you see that kind of collaboration along the...
Collaboration is essential, that's for sure.
Yes.
But you have to be an intelligent person to interact. So you need some background to ask the right questions and to be critical of what you hear. And so to be a better contributor, you must have some good background. And then you can interact correctly. Yes. Otherwise, you're always on the reacting rather than proacting or for leading research. And so collaboration is essential, but you need to have some good background.
I see that, and we always encourage the young generation. You have to have the basics, so at least you have the same language. And this is one of the things, like, okay, the industry are sometimes complain. So how do you see the collaboration between the academia and the industry, or your collaboration was your experience was collaborating with industries or municipalities?
Well, collaboration with industry and municipality, I'll just come back to that in a second. Grad students should have an experience in not only the specific aspect of their research, but maybe some other parallel aspect as well. And if you can work with the pilot unit, getting your hands wet, getting to interpret the data, screening the value, validating the results that you have, because when you are a consulting engineer, you take the value as granted, and that these are true values. But when you dealt with the data that you obtained, you know that some values don't make sense. And so you have this appreciation of the quality of the work. And so having had the chance to work with pilot units is really great. So somebody who does modeling, for example, strictly, should get a complementary experience with running some pilot units. Even if it's only assisting, but getting into the interpretation, the analysis, that's essential. And that's an experience that will be beneficial when he becomes a consultant, for example, or professor. Then he will know what is the limit of validity of all the results and what he can get. So now, as a consultant or as an industry, then people are looking for this kind of critical expertise, not just the message. Believe me, okay, you don't want to believe, you let me be convinced. I can be convinced of anything. Yeah, you have to convince me now.
Exactly. Yeah, but maybe it's a good chance for the grad students if they got a chance to work on a pilot or some scale-up experiments. Not all of them got that chance, but they should open their mind to know about those things.
They should do some kind of internship if they could.
I think that's something maybe we can discuss with the scholarship grants to focus on something like that. And this is one of those areas, like, okay, when you go to those postdoc scholarships like MITEX, for example, have to get interaction with the industry to get more, and this is maybe take you to the level of the pilot or the full scale. But going back to the collaboration with the industry and or municipalities, I'm pretty sure that you are collaborating a lot with industries and municipalities. How do you see that collaboration with industries and municipalities benefiting your research?
Well, the most important thing is to listen. Okay.
Okay.
So you talk to these people, listen to their challenges, and from what they tell and from your experience, you can see if you can contribute to helping them with their challenges, rather than say, I've got the key, what kind of door can I open? So let them open the doors and see how you can fit. Is an interesting approach that is quite fruitful and appreciated by collaborators from municipalities and industry. They have their challenges. So if you can tell them, if you can contribute to alleviate these problems and to find solutions, they will very much appreciate it. And that gets into other projects and of collaboration because the confidence builds up. So first thing, listen.
Listen, you have to listen. Listen, understand, yeah.